Okay, the title of my presentation is Ontologies to Improve Reusability of Food Data, Knowledge and Model in Decision Support Systems. Next, slide 3 now. No. I will begin by a brief overview presentation of INRA. Next is slide 4. INRA is the European first and world's second greatest producer of publication in the agricultural sciences. It is a community of around 12,000 people, split in 250 labs all around France, with an annual budget of around 880 million euros. My team, it's a common project team of around 20 people, all computer scientists, from 4 different institutions: INRA, University of Montpellier in the south of France, INRIA and CNRS, and all the INRA members belongs to the INRA Food Technology Department. Slide 6. Now I will present briefly 2 examples of a decision support system we have designed, which are reusing data previously annotated with food ontologies. Slide 7. The first example of decision support system permits to realize food packaging selection. It's a work we have done in the European project EcoBioCap, which finished last year. Next. In this decision support system, we want to be able to answer to queries like, I want a packaging which preserves my product made of renewable resources, but without GMO, if possible transparent, and with a material cost inferior to 3 euros per kilogram. So we want to do some multi-criteria selection of food packaging. Next, slide 9. Here I present on this slide the global decision support system architecture, which is based mainly on 2 databases, a fresh produce databases and a packaging database. From the first fresh produce database, it is used in order to provide input parameters to a numerical model, which is able to compute optimal O2 and CO2 permeabilities for targeted packagings. We also are able to aggregate preferences of the stakeholders using argumentation theory tools. And all those preferences are input parameters of a multi-criteria flexible querying system, which is compared to a collection of packaging which are stored in the packaging database. And after this querying, we retrieve a ranked list of most relevant packaging. Next slide. You can see on this slide 10 a screenshot of a decision support system. In the upper part, we select a food. Here it's an apricot, and we express the mass of the quantity of apricot, 500 grams, the shelf life 7 days, the temperature of storage, and we retrieve from the food produce database respiration parameters. Thanks to all those parameters, we have a numerical simulation model which computes the O2 and CO2 optimal permeabilities for storage for the relevant packaging. And those information in the lower part of the slide are used in order to query in a multi-criteria way the packaging database. Next slide. We can see on this slide some results obtained. The first one is the best packaging. It is a polyethylene HD, and this decision support system permits to reduce the number of experimentation to only 1 pack, the most relevant. Of course, it is a reduction of cost and reduction of the duration of the study. Next. It is a multi-criteria comparison of innovative sustainable processes. Slide 13. Therefore, what we want to do here in this decision support system is to compare different innovative pretreatment of lignocellulosic biomass in order to transform it into glucose. And on the next slide, we see on slide 14, we see the decision support system architecture. In the first step, we use an ontology in order to extract from the scientific articles relevant information, which will be stored in an RDF database in the second step to compute some environmental impact indicators. And in the third step, those indicators will be used in order to rank the innovative processes. On slide 15, we can see the result we obtain in the point which are presented on the drawing on the different innovative processes, and the one which are surrounded in green are the one which have the best environmental impact, and the one which is in the lower right part is the one which has the higher glucose yield. Therefore, it seems to be the better here. Next slide. Now, as we have seen how we reuse the data in decision support system, I will present briefly the tool we have developed in order to standardize the data from heterogeneous data sources using ontology. The next slide, the slide 17. On this slide, I present the software we have developed, which is called IATE for annotated data of the web. In fact, this software permits to manage ontologies, to manage the evolutions of ontologies in the first step. And after that, we can use this ontology firstly to annotate heterogeneous data sources. For instance, here on the slide, we have characteristics of commercialized packaging in PDF formats, which are written in French, and also characteristic of innovative packaging from scientific articles in HTML format and English. And all those different sources are standardized thanks to the ontology in order to obtain a standardized representation of data. Next slide, the slide 18. Here I present briefly the terminal ontological resource template we use in IATE. It is in fact a generic template which is based on the NRA relation concept classical in relational database. It is in the left part of the picture, and when we want to reuse this template, we only have to redefine the domain ontology, which is in the left lower part of the slide. And next slide, slide 19. Here it's a first example of ontology we have developed, and it's a matter transfer terminal ontology dedicated to food and packaging matter transfer characteristics. Here represented on this slide the O2 permeability measurement associated to a packaging and with all its control parameters, the thickness of a packaging, the temperature, etc. On the next slide, slide 20, it's another example of ontology we have developed using our template. Here it is dedicated to the modeling of unit operation to transform biomass. Here I have an example which presents the milling operation with input flow, output flow, and control parameters. On the next slide, slide 21, we switch to current development. We want to make ontology network to manage traceability between agricultural data and food transformation data. Next slide, the slide 22. Here it's a screenshot which presents on the left part an ontology we have developed to annotate data from the viticulture, from the vineyard. And in the right part, we have another ontology which is used in order to model winemaking, and we have made some semantic links between those two ontologies in order to build an ontology network. And thanks to this ontology network, we have a possibility to make the traceability between berry grape samples till the finished wines. On slide 23, It's my conclusion. Therefore, we currently developed a 5-star linked open data tool to annotate scientific data using ontologies. We reuse this annotated data in decision support systems. We have presented 2 examples. And currently, we have several INRA teams which design agriculture and food ontologies dedicated to specific domains. And we have decided to group all those different contributions in the Love INRA group in the Agro portal, which will be presented in the next session by Clément Jonquet. Currently, we are involved in new European and international projects to design new ontologies about food texture, durable quality, and to structure heterogeneous data sources accordingly. Thank you very much. That's the end of my talk.